In this video, I'm going to show you how to use the polyfit function in order to fit a polynomial to noisy data. First, I'm going to show you how Matlab can interpret a vector as the coefficients of a polynomial. So consider the function x squared minus 1. We know the roots of that should be x, so I'll write in the comments, so x equal 1 and x equal minus 1. The way we can do that in Matlab is by specifying the coefficients. So we have coefs 1, 0, and minus 1. So whatever's in this position over here, Matlab will interpret as 0 degree, and then first degree and second degree, and so on and so forth. And so one example of a function that uses this is the roots function. And so the way we use that is just roots and then coefs. And so there we go. We get minus 1 and plus 1, just as we expected. So let's consider an example where we might have some noisy data. And in this case, we're just going to simulate it. So x minus 50 to 40, y is minus x squared, and minus 10 times x. Okay, so notice I use this dot notation here, and all that says is that we're going to do this operation for each value of x. And let's also add some noise. So y equals y plus 500 times rand 1 to the length of y. And let's just see what that looks like. So figure 1, plot x, y. Okay, so this is what we get, just about as we expected, or you may have expected. And so we want to fit a polynomial to this. So the way that we're going to do that is using the polyfit function. So just as before, we're going to specify, not the same as before. The polyfit function puts out the coefficients of a polynomial of a given order. So you specify your x and y data, and then also the order that you think it might be. So let's have coefs equals polyfit x, y, and we already know it's second order, so let's just go ahead and take a guess. And then, so we can do that, and we can print out coefs. And we get minus 1, 9.98, minus 9.98, and 260. And if you look back up here, that's pretty close to what we already have. And if this is throwing you off, it's coming from right here. So yeah, now we're going to want to evaluate this function, and we can do that using another function called polyval. And so that will be polyval coefs. And then, so you specify your coefficients, and then you also tell the polyval function where you want to evaluate those coefficients. So we just want to evaluate them along the same vector x. And then let's plot that again. So figure 1, plot x, y, and then x, y, fit. And so let me bring up the graph. And there we go. We get a pretty nice fit. And yeah, it reasonably estimates this function, and just as we expected. And it can be applied to real data, which is a nice thing.